This call is now being recorded.
Yeah. Okay, a quick recap of yesterday's class. So yesterday we discussed about the instrumentation amplifiers, the various advantages of instrumentation amplifiers, why they are used in the first stage of the any sensing system. So we discussed about two op-amp instrumentation amplifiers and the improved version of two op-amp in instrumentation amplifier, that is three op-amp based instrumentation amplifier. Few disadvantages are associated with the gain and common mode rejection ratio of this two op-amp based instrumentation amplifiers, as the common mode rejection ratio is dependent on the frequency and it improves with high frequencies. So at low frequencies there is a issue with the common mode rejection ratio, which does not help in amplifying the signals or rejecting the noise signals and amplifying the microvolt level signals in this case. So a slightly improved version which includes two stages of differential amplifiers is designed, and according to this here you can see in the first stage one fully differential amplifier stage is present, which helps in improving the common mode rejection ratio, also helps in DC offset adjustment, and drift is made almost zero. The same performance is improved in the second differential amplifier stage, where the comparison of the two voltages, that is VA and VB, with this V reference improves further the gain and CMRR of the entire instrumentation amplifier, which is necessary for any sensing system design. With this understanding of instrumentation amplifiers and also the improvement in the input and output impedances and the necessity of high input impedance and low input impedance, how it helps in actually amplifying the voltage signals. So with this understanding, we will go to the next bit, that is interference. Now, once you design these instrumentation amplifiers with required gain, required common mode rejection ratio, usually it is for instrumentation amplifiers around 70 to 120 dB for 3-stage. For 2 op-amp type, it is less than 60 dBs. Maximum you can go up to 60 dBs. So this improved common mode rejection ratio helps in rejecting the common mode signals which are going to be originated due to different interferences happening at the sensor end. So this sensor end sensing should be so accurate that these interferences should not be transmitted to the next stages. And the measurement should be so accurate that the errors which are generated here, they should be in the instrumentation amplifier stage itself should be suppressed. Now, what type of interferences are possible here? Now, basically understand one thing, all our electronic devices are going to be associated with either resistors or capacitors or sometimes even inductive couplers. Also, whenever we are using these sensors, most of them fall in any one of these categories, like resistive type, capacitive type, or inductive type, especially the electronic signals. And there are, of course, other signals like gas type, gas sensing type. So such ones also, we prefer them to convert them to their electrical equivalent and then condition them. So always you have either electronic or electrical components coming into picture. So when you have always these electrical components coming into picture, the interference also can be generated due to these components only. Now, what exactly is the meaning of interference here? Now, basically the interference in this case is the signals which are generated or which affect the measurement system, and they do not come under the sensing element, or they are not basically generated by these sensing elements or the parameter under test or sensing. They are externally generated signals, but still they are sensed by the sensor. They have got nothing to do with the parameter under measurement due to the external environment or ambience or any other resistor or capacitors connected to aid the measurement system. They are generated by them but sensed by the sensor. So these are the interference signals. So that is why here the principle of sensing is basically to sense the parameter under test. But if these signals which are generated are not by these parameters but by the external factors, so those are also sensed as the parameter under test only. So under such cases, these signals create problems in the next stages if they are taken as valid signals, not considered as noise signals. So interference is any electric signal present at the output of the system or circuit being considered and coming from a source external to it and not from sensor. Now the next point is how to reduce these noisy signals or the interference signals. In communication system, we have different mechanism to reduce these noise signals, especially the filters which are used to reduce these noise signals. And in sensors, what mechanism is adopted to suppress these noise signals? First thing, we are using instrumentation amplifier basically because in the differential stages, you can minimize these. But if the sensor is giving out, or if the sensor is sensing all these signals and not knowingly that these are noise signals, then definitely they will be reaching the instrumentation amplifier end. So in the sensor stage itself, they should not be sensed. So for this, we need to know what type of interference or from which element the interference is caused. So there actually you have in the circuit capacitors, inductors or resistors. So because of this, they can be generated by any one of these. So they can be by the simple source impedance from source to the sensor, whatever there is a connection. So in that, whatever impedance is there, that may be causing you the interference. And if the source impedance is available, then that source impedance can be resistive, capacitive or inductive depending upon what source you are using. If it is a AC source, you can have capacitive and inductive type. If it is a DC source, then you have resistive type of material or the resistance getting added, which may cause interference. If the coupling is through a capacitor, then it can be giving you the electric field, additional electric field may be getting generated, which may be causing the interference signals. Similarly, if you have inductive coupled sources, that could be generating the additional magnetic field, which is noise. So the interference can be classified as resistive, capacitive or inductive due to the coupling devices. Now, how to avoid them? Because without source, you cannot go ahead. And especially in case of resistive type of sensors, always source is a requirement. In case of self-generating type, these source-generated interferences can be avoided. But in case of resistive type, all these are going to be present.